Hey guys, welcome to 13.2. In this section, we're going to be talking about angles and the unit circle. So basically, this is going to be specific aspects of the unit circle, which I covered in that really long video on the unit circle, which once again, I apologize for that video being so ridiculously long. This is going to zero in on certain aspects. So if you didn't get it in that video, it's fine. I'm going to be talking about it more in depth in this video. That was kind of an overview so that you kind of understood what the unit circle is, why it's important, how it works, at more of an overview basic level, and then we're going to get into some detail here. So that being said, let's do it. So first of all, I want to talk about how we define some angles. So we always measure the angles off of the positive x-axis, so this side here. And then it goes, if the angle is positive, then we go counterclockwise to the terminal side. Terminal meaning where it stops, right? If something terminates, it stops. So the terminal side is where the angle stops. So in the positive angle will go in counterclockwise from positive x-axis to the terminal side, and a negative angle would go clockwise from the positive x-axis to the terminal side. So that is that. If we call two angles coterminal, coterminal means that they have the same terminal side. So if I have two angles that look exactly the same, like say I had the positive version and the negative version, they have the same terminal side, but I'm just measuring them in a different way, I would call those coterminal angles. We'll talk more about that later. We can use information about the coterminal side. For example, I know that -2, -2, that point is on this coterminal side. I can use that to figure out what this angle is. And I'm going to talk about a shortcut that I want you guys to know. If this is my reference angle, remember in that video on the unit circle I talked about reference angle, that's going to be your first quadrant angle. So if I had this but it was over here, so that this angle matched this angle, so I have an angle here, this is theta, this is going to be my reference angle. If this theta matches this part of the angle, so it's not the whole angle, it's this part of the angle, this is going to be my reference angle, so that's theta. Then if my terminal side were in the second quadrant, then my theta would be here. This part here is 180 degrees, yes? Yes. So this is 180 degrees. If my angle is in the second quadrant, then my actual angle is going to be 180 degrees minus that reference angle. Because 180 degrees would take me here, and then if I'm in the second quadrant, I would subtract that reference angle, and then I would be somewhere in the second quadrant, right? So second quadrant is 180 minus theta, or in radians, that would be pi minus theta. In the third quadrant here, which is what we actually have, would be 180 plus the reference angle, right? Because we go 180 and then we keep going plus the reference angle. So this is 180 plus theta, or pi plus theta for in radians. And then in the fourth quadrant, we measure always off of the x-axis. So I'm going to think of this as being 2 pi instead of 0, because we're going to go, if we go all the way around and then back down the reference angle, so all the way around and then come back the amount of the reference angle, that's going to be 360 minus the reference angle. So these are shortcuts that you really should kind of get into your head. Yeah. So in pre-calc, we use this a lot, mostly the radians version. So in pre-calc, this is something that you would definitely memorize. Yeah. So these are basically the shortcuts. If you know what quadrant you're in and what your reference angle is, then you use these shortcuts to find out what your actual angle is. And you're probably wondering, why am I even telling you this? Because I don't know what my reference angle is. Well, that's the point, is that we're going to find the reference angle. So the reference angle is just the angle off of the positive x-axis. We can talk about it being in the first quadrant, but it doesn't really matter because it's just an angle measure, right? So this angle and that angle are the same. So I can find this angle by treating this like a right triangle. It's kind of small, so I'm going to redraw it bigger. Now 2, -2, since those are the same, I can actually know just based off of what I know about 45, 45, 90 triangles, that this is a 45-degree angle. But if they weren't the same, I would need to do this. So we're going to do the use this right triangle to figure out. So I expect this to be a 45-degree angle because these two are the same. But let's use this triangle to make sure that that's true. So this is saying I have -2 in the x direction and -2 in the y direction. So this is -2 and -2. I don't know what this is. Doesn't really matter. I need this angle. And so I have the adjacent side of my triangle and I have the opposite side of my triangle. So the trigonometric function that uses opposite and adjacent is tangent. Remember, tangent of theta is opposite over adjacent. So I'm going to use that information. I know that tangent of theta is -2 over -2, opposite over adjacent. So tangent of theta equals 1 in this case. And so in my calculator, I'm going to put tangent or inverse tangent of 1, and that will give me theta. Again, this is my reference angle. So putting that in a calculator, there are inverse trig functions are usually right above the trig functions on your calculator. So if you put shift tangent, that's inverse tangent. And 1, and it is in fact 45 degrees. I could also know that tangent of 45 degrees is 1 if I know my unit circle, and I wouldn't even have to use a calculator for this. So that's another reason that we kind of get the unit circle into our head, so that when we have these easier ones, we don't even have to go to a calculator. We can say, oh, I know that tangent of 45 degrees is 1, so the inverse tangent of 1 must be 45 degrees. But anyway, putting this in a calculator, we get theta equals 45 degrees. And so I know that the reference angle is 45 degrees. But that's not my final answer. My final answer is, what is this whole thing? Well, I'm in quadrant 3, so I have to do 180 plus theta. So 180 plus 45 degrees, which is, what, 125 degrees? Pretty sure it's 125. Not 100, 225 degrees. Yeah. So this whole angle is 225 degrees. That's my answer. One quick note about putting these in a calculator. Even if you get a negative here, so say one of these had been positive and one of these had been negative, for the reference angle, you're always going to want to put the positive version in the calculator. So it doesn't matter if it's tangent, cosine, sine. When you're putting, when you're finding your reference angle, you can ignore the negatives. Just put the positive version in the calculator. The reason for that is that that's the only way you can guarantee you're getting your first quadrant answer. If you put a negative in an inverse tangent, any inverse trig function, you're either going to get second or fourth quadrant. Two of them will give you fourth and one of them gives you second, and you don't need to know which is which right now. But the point is, if you're putting a number in an inverse trig function, just put the positive so that you know you're getting your first quadrant answer every time. In pre-calc, we'll go into why you get the answers you get when you put in a negative. For now, just always put in a positive number into an inverse trig function. Okay, so I'm going to stop this video here because I'm thinking it's already getting a little long, and we will do the next example in the next video. Let me know if you have any questions, and I will see you guys in the next one.